Integer is the mathematical name for a number that can be positive or negative, or zero. So what is a negative number anyway? Well, first let's start with zero. Suppose I give you $5. Then I take $2 back. Then I take back $3. How many dollars have you got left? Of course, you don't have any dollars. But we really would like a number to represent that state, so that our bank account can still have a number instead of our having to say, there is no money left in this account. So we say instead, the balance is zero. Think about this carefully. It's actually a very abstract concept. Zero becomes a new number, representing not having any. I can't actually point to zero of anything, because they don't exist by definition. It's not a whole number, because I don't have any whole things. But it's definitely a very useful number. Okay, so what about negative numbers? Well, just like zero, it's an abstract way of keeping track of things when, well, to be honest, when there isn't actually anything physical to keep track of. Suppose again I give you $5. Then let's say I take $7 from you. What's the balance of your account now? It's $2, but now I owe you instead of you owing me. It's $2, but I can't actually point to the $2 in your hand. I have to point to my own hand instead in this case. So there's the idea of $2, but there aren't two whole anything that you actually have. How are we going to represent this in our account balance? What we do is invent negative numbers. We say the balance is -2. That means it's $2, but in the opposite direction, so to speak. Some people call negative numbers directed numbers. We'll come back to this idea again when we look at performing operations on integers. Okay, so if we can never actually point to -3 of anything, do negative numbers really exist? And this is where mathematics takes a turn towards the abstract. A mathematician will say, yes, the number itself exists as an abstract concept, even though you will never actually have a negative number of anything in the physical world. Mathematics is really a study of abstract ideas and abstract truths. And occasionally it may actually be a useful way to do things in the real world, but that's a bonus. Remember when we talked about whole numbers, and we said that the number or meaning was an abstract concept, represented by the numeral, which we write using the digits. The number 13, the idea of having 13 of something, was represented by the numeral 13, a 1 followed by a 3, made up of the digits 1 and 3. Well, now we have the idea, the concept of having -13, if you like, the idea of a lack of 13 things, or 13 steps in the opposite direction, or whatever, represented by the numeral -13, written -1, 3, made up of the digits 1 and 3, and now also the symbol minus. It's exactly the same as it was with whole numbers. The number itself is abstract. It's just that now I can't point to anything physical in the real world to show you what the number represents. Just like with whole numbers, one of the simplest ways to represent and work with integers is with a number line. Except our number line now goes backwards past 0 into the negative numbers, as well as forwards from 1 through the positive whole numbers. We're still applying the convention that positive numbers increase to the right. So what's the first integer? As with whole numbers, there's some disagreement. Most people would still start with 1. The first positive number is certainly 1, and the first negative number is -1. But others say 0 because it sits neatly in between the positive and negative sides. And there are some other nice theoretical reasons too that abstract mathematicians like because of the way number theory and group theory work. That's well beyond us here. You decide for yourself. Personally, I like 0. The smallest integer then is 0, because 0 means you have none at all. Or is it? Wait a minute, don't they get smaller numbers by moving left on the number line? So then the smallest number would actually be, well, negative something very big? We have to be careful with our language here. If the positive numbers increase to the right, does that mean the negative numbers increase to the left? Or are our numbers decreasing as we go to the left? This is a tricky question, and we're going to solve it by establishing another convention. There has to be a difference between bigger and greater than, a difference between smaller and less than. With whole numbers they're the same, but with integers we have to be more careful. Most people would say 3 is bigger than 2, so we'd like 3 to be bigger than negative 2. But what about negative 3 and 2? And which is bigger, 4 or negative 4? By convention, we're going to say that numbers to the left on the number line are less, and numbers to the right are greater. And we're going to try to avoid using words like bigger and smaller when the answer is ambiguous. That means a positive number is always greater than a negative number, regardless of the size of the number. Actually, mathematicians use the word magnitude instead of size to avoid exactly this confusion. The magnitude of a number is its distance from 0 along the number line, regardless of direction. So 3 is greater than negative 2, negative 3 is less than positive 2, and negative 4 is less than positive 4.